Hey, welcome back. In this final video on graphical user interfaces in Python, we are going to incorporate a machine learning model into our app. So in the previous lectures, we saw how to create the very simple kind of graphical framework of an app with windows and frames and text labels going on inside there. Then we saw how to accept user input and incorporate that input so far in a very, very simple way into the output of the app. Now we are going to do something a little bit more complicated. We're going to bring in a machine learning model that we trained in the previous video. We are going to create a button that the user can click to say, hey, please make a prediction using this model. And then we're going to display a helpful and neat output to the user. So that's the agenda for today. If you remember from last time, so kind of where we got to was we were able to run an app. We were able to prompt the user for different kinds of input, including both from drop-down menus and from text entry. And then we also showed a way to just sort of spit back what the name of the island was in that bottom field. We have suppressed that for now because we're going to put something else in there. So this is kind of where we were when we got started. So now let's go ahead and take it to the next step. So as we saw in the last video, we can grab pre-existing Python objects if we save them using pickle. So we can do the first thing, we can import pickle. And then we can do t equals pickle.load. So we're going to load using a connection to the file model.p with reading access. So this line will now give me a machine learning object. It's a decision tree classifier that we made in the previous video. So with that line in place, I'm now ready to begin using my machine learning model. Now, there are a few details to take care of. First, remember that the machine learning model uses a label encoder so that the names of the species and the names of the islands are both represented as numbers. This is not desirable for the user. So we want the user to be able to pick an island and have that island be translated into its encoded number. Then when the algorithm gives back a number, we want to be able to translate that number back into a species. So let's go ahead and just create two dictionaries for that. So I'll do island dict. And I'm just going to create, let's see here, I'm going to create Bisco. So Bisco Island under the label encoder is island 0. Dream under the label encoder is island 1. And Torgerson under the encoder is island 2. So there's my dictionary of islands. And then similarly, my dictionary of species, species dict. So I'm going to do, so in the algorithm's label encoder, addly corresponds to 0. So I'm going to create a dict in the opposite direction now so that when I see a 0, I can say addly. Then 1 corresponds to chinstrap. And then 2 corresponds to Gentoo. Okay, so now we have the ability to translate easily back and forth between our label encoded representations using our label dictionaries. Okay, so the next item on the agenda is to create a frame answer, is to create a function that we are going to use to create the answer for our app. So I'm going to create a new text variable. So answer var equals tk.string var. String var is the tk-enter representation of a variable piece of text. And now what I'm going to do is create a function that modifies this answer var. So I'm going to do def make prediction. Now, in a moment, we'll fill in this function, but for now, I just want it to be empty. So I'm going to have it pass. And then I want us to look at how to create a way to trigger this. So actually, yeah, let's have it pass. So we're going to give this function some content, but for now, we're just going to have it pass. OK, so here's what we need to do in order to trigger this function. We're going to create a button, okay? So I'm going to create a button called button run. What the button run does is it runs this function, make prediction. So I make a tk.button object. Okay. This button object is going to live in the frame answer widget. So that's where it is located. Its text is going to say update, let's say update prediction, why not? And then let's make it look a little bit distinct. So we'll say that it looks raised relative to its surroundings. Its width is 10, maybe we'll mess with that. And we'll give it a font, let's say Helvetica 12 bold. Okay, so that's the appearance of the text in this button run. Okay, so we've created a button, and like everything else in tk-enter, we're not going to see it in the app until we locate it using something like grid or pack. For now, let's use grid. So I'll do button run.grid. Let's have it go in column 0 and row 1. The reason why we're putting it there is that column 0, row 0 will be the answer itself. And then we are going to make it sticky with W, and we are going to use some horizontal and vertical padding as well. Okay, and if you're wondering about these settings, I don't really have a good answer for you here in terms of principles. A lot of this is trial and error and see what looks okay or at least readable. So now let's try running this code. So if we run this app, let's see, we are going to get an error here related to grid configure. Okay, so I'm just going to specify the column equals 0 and row equals 1, see if that helps. Let's see, now try. Yeah, there we are, okay. Yeah, so now what we have is this nice new button that's appeared in our answer area. We can click the button. So we click the button, and when we click the button, nothing happens. So that's because we have given our button so we've given our button some behavior, but the behavior doesn't really do anything at the moment. So what we need to do, oh, sorry, and the reason why it has literally no behavior is actually because I've forgotten the step, sorry about that. So there's one more piece to making the button, and that's specifying the thing that should happen when the button is run. So I've forgotten a line here. There's a command argument to a button, and the command argument is a function that is called when the button is pressed. So the function that we're going to call is called make prediction. Okay, so we're going to use the make prediction function that currently doesn't do anything, but later it will. So when we press this button, the make prediction function will run. Additionally, I'm just going to change update prediction here to update, so I think that makes the button a little easier to read. Okay, so now when I run this code, I should see the same thing. So update is a little bit easier to read now. And when I click update, again, nothing happens. This time, the reason nothing happens is that I'm calling the make prediction function using the command argument of button run. However, the make prediction argument doesn't do anything yet, so nothing is happening. Okay, so now we need to go in and start filling in the pieces. So let's go ahead and begin to do that. The first thing I'm going to do is display the answer variable. Okay, so the answer label. So the answer label is going to be a TK label that allows us to display the variable. Remember, we defined an answer var string variable, so we're going to display that. Okay, so we're going to display this variable. We're going to do it in frame answer. Let's change the font just for kicks. Let's say it's Arial 16 and bold. Okay, that's fine. Then we are going to set a boundary. We're going to set an anchor to sort of tell it where to live. And then we're going to do a text variable. So the text variable that we assign to the answer label, that text variable is the answer var. And let's give it a white background. Okay, so now we've created a label that will let us display this answer variable that we created above. And then we'll place it on the grid. So answer label.grid, row equals 0 and column equals 0. Why not? So now if we run our code again, we see that now our space has expanded. So it looks like now something is supposed to go above the update column or update button. But there's nothing there because the answer variable doesn't have any value. Okay, so what we need to do now is to give it a value. So one way to give it that value, so here's kind of a simple way. So if I take this answer variable, and I'm just going to start this right above the make prediction function for now. So if I take the answer variable and I do answer var.set, let's see, to boldly go is a good string. So that gives the answer variable a specific value using a Python string. And hopefully now if I run my code, I'll see that I've displayed that value right above the update button. So this is roughly where I'd expect it to go. But of course, this isn't the right string. So now my task is to use my machine learning model that I just created, as well as these auxiliary dictionaries, to create the right string to go in that spot. So this means that it's time to fill in the make prediction function. We've set up the framework that we need. We have everything in place, except that we just need to be able to assign a standard Python string value to answer var. So let's see how to do that. So what we need to do is remember from our previous lectures that we have var1, var2, var3. So var1, var2, and var3 are the user inputs for island, body mass, and column length, respectively. So that means that we can create an array of predictor variables like this. So I'll do x. So the first entry of x needs to be the island represented as a number. So that means I need to use the island dict to get the dictionary value corresponding to the key contained in var1. So I don't pass var1 directly. I use the .get method of var1 to obtain var1's value in a way that Python can work with it. So I use island dict var1.get. So for example, if var1 is Torgerson, for example, then island dict of var1.get will be 2, representing the label associated with Torgerson. Next, I need to pass the body mass. Now remember, these are text inputs, which means that I need to convert them to numbers before I try to do any prediction with them. So that means I'll do float var2.get. So I take the value of var2 as specified by the user, and I turn it into a floating point number. And then finally, I'll do the same thing for var3. So now I have an x containing 3 numbers, and these 3 numbers include the numeric representation of the island according to the label encoder. They include the user-supplied body mass and the user-supplied column length, and I've used the dictionaries and I've used the float conversion to ensure that I now have an x, which is a 2-dimensional array of containing 3 different numbers. This means that we are all set to get a prediction from our machine learning algorithm that we loaded in. So here's ypred. Ypred is the prediction of the algorithm. It will be t.predict of x. Okay, now we can do a little bit better than this. So this is very, very simple, and we can just make it a little more complicated. First, syntax. When t returns a t.predict, it will return the prediction as an array. We don't want an array, we just want a single value. So I'm going to grab that value just by adding an index 0 there. I get what's inside the array, not the array itself. That's item 1. 2, we're going to pass that through the species dict. Okay, so I'll do species dict of that output, and then that means that I will get not a number 1, 2, or 3. I'll get the name of the species, Adelie, Chinstrap, or Gen2, 0, 1, or 2. Sorry. So now I have in ypred a string giving the name of the species that the model thinks is appropriate given the inputs. So now from here, it's very simple. So here's our answer string. You might be a or an plus y pred plus penguin. So if the model thinks that you might be a Gen 2 penguin, then the answer will say you might be a Gen 2 penguin. Okay, and then finally, we saw this earlier, we need to set the answer var to that value. Okay, our function doesn't have to return anything. All it needs to do is update the answer var. Okay, we already have things set up to display the answer var. So if we haven't made any mistakes, we might be all set to go. So let's try it. Okay, here is our new app. So what I'm going to do is I'm going to specify my island. Let's say I'm on Bisco. I'll be a penguin of 4,000 grams body mass. And let's say my common length is 45 millimeters. I'll update, and here's my prediction. The model thinks I might be a Gen 2 penguin based on what I've provided. If I instead say, okay, well, I'm a Torgerson, and then hit update, the model thinks I'm more likely to be an Adelie penguin. Or if I go to Dream, let's see what happens then. Oh, the model actually thinks I'm a chinstrap penguin now if I'm on Dream. So in this video, what we've done is we've added just a little bit to our tkinter knowledge. For example, we saw some buttons. We used our button to call a function and used this function to update a label that would be displayed to the user based on their input. We saw that it's very, very easy to incorporate machine learning into your app if you've already done the machine learning. If you've already built your model, then all you have to do is save it and load it using Pickle, bring that into your app using pickle.load, and then you're all ready to go making predictions. This is much more like how real software operates. So there's a lot of software in all of our lives now that uses machine learning. Those software tools are not training a model every single time you use them. Instead, someone else is training the model, and then those apps are just loading in that already trained model to use in the app itself. So this is a bit more like a pattern that you might see in real production software. Okay, that's it for our exploration of graphical interfaces in Python. Now look, there is a ton more that you can explore here. You can explore ways to add radio buttons and multiple choice and all kinds of other features to your app. You can look at images. You can look at making your app look really good because you know what? Our app looks a little bit janky as it is. There are lots of tools that you have to make something that looks really professional, that has many opportunities for your user to interact with it, that does more rigorous checking of the inputs to ensure that the user is always inputting something valid that the model can interpret. So there's lots more to explore here. And I really encourage you to take a look at the tkinter tutorials and documentation because you can see some really cool stuff there. Okay, that's it for our discussion of graphical interfaces. Thanks for following along.